All right, let's get right into it. We're going to talk about a concept that's absolutely at the heart of cloud security. It's called the trusted computing base. And you know, it's basically the bedrock that lets us do sensitive work on computers we don't even own. And really, that's the billion-dollar question, isn't it? I mean, think about it. You're taking your most critical stuff and handing it over to someone else. So how in the world do you build a fortress of trust inside a data center you'll never even see? Well, the answer starts with making your foundation of trust incredibly clear, incredibly small, and incredibly secure. So, to make this whole thing click, we're going to use an analogy. Just imagine the cloud provider's entire system, all their servers, their network, the whole shebang, is one giant bank. Your secure space inside that bank, that's your own personal super tough vault. And that vault is your trusted computing base.
Okay, so first things first, let's define what this vault actually is. What are the walls made of? What makes it so special and secure? Because really everything else we talk about is built on this foundation.
So the official term, Trusted Computing Base, or TCB, is basically everything that has to be trusted to keep your stuff safe. And I mean everything. The physical hardware, the firmware that makes it run, and the software on top. The key here is that phrase must be trusted. Because if even one of those little pieces gets compromised, well, the whole house of cards can come tumbling down. Now, this might sound a little backward at first, but it is the single most important rule here. A smaller, simpler TCB is always more secure. Why? It's pretty simple, actually. The fewer moving parts you have to trust, the fewer things can go wrong. There are just fewer doors for an attacker to try and open. It's all about security through simplicity.
To really get a handle on this vault, we've got to understand where its walls are. We need to draw a clear line in the sand. What's inside the protected zone and what's left on the outside. Getting this boundary right is what confidential computing is all about. And this right here, this lays it out perfectly. Inside your TCB, inside the vault, you've got your actual work, your data, your code. It's all running in something called a trusted execution environment, which you can think of as a sealed-off, secure bubble right on the processor. It's completely encrypted and opaque. Now, everything else, the cloud provider's operating system, the hypervisor that manages all the virtual machines, all that stuff is outside the vault. They can see that the vault exists, but they have no idea what's happening inside. To them, your workload is just a scrambled, unreadable black box.
But wait a minute. How do you know you can trust the vault itself? How do you know it hasn't been tampered with? Well, that trust is physically anchored in special tamper-resistant hardware from chip makers. This is called the hardware root of trust, and it uses powerful cryptography to prove that your secure environment is legit. This whole process, called attestation, is kind of like getting a digital certificate from the manufacturer saying, yep, the seal on this vault is authentic and unbroken. Okay, so here's where it gets interesting. Just like in a real bank, you don't just have one size of vault. You've got different options for different needs, and the same is true here. Let's look at how this actually plays out with different kinds of technology. On one hand, your vault can be, well, massive. Think of it like renting out an entire secure room in the bank. In this case, your TCB includes the entire virtual machine, its operating system, everything. This is awesome when you want to move an existing application to the cloud without having to rewrite it, a lift and shift approach. But on the complete other end of the spectrum, you can shrink that vault down to something tiny. Think of a single ultra-secure safe deposit box. Here, you're not trying to protect the whole machine. Nope, you're just protecting one tiny, critically important piece of your code, like the function that handles your encryption keys. This is for your absolute crown jewels. And this table kind of breaks down those trade-offs for you. You've got confidential VMs, or CVMs, with that big TCB protecting the whole machine. Super easy to use, but the trade-off is a bigger attack surface. Then you've got things like Intel SGX, which lets you shrink the TCB down to just a tiny bit of code. That's the most secure option for sure, but it does take more work to set up. And then you have containers in the middle, trying to give you the best of both worlds. The big takeaway here is that you're always balancing ease of use with the level of security you need. So let's bring this all home. Let's focus on the so what. Why did we just spend all this time talking about the size of your trusted computing base? At the end of the day, it all comes down to this one simple truth. A smaller TCB means a smaller target for attackers to hit.
Every single line of code, every piece of hardware inside that trusted boundary is a potential weakness. So by making that boundary as small as possible, you are directly and fundamentally reducing your risk. Less stuff to protect means less stuff that can be broken. Period. So if you walk away with anything from this explainer, let it be these three things. First, the TCB is your absolute security foundation in the cloud. Second, a smaller TCB is a stronger TCB. And third, there's no magic bullet. You have to pick the right size vault for the job you're doing.
And that leaves me with one final question for you to think about. As we keep pushing more and more of our sensitive data into cloud environments that we don't physically control, we have to ask, is the size of our trusted computing base the single most important security question that most of us just aren't asking? It's definitely something to chew on.